Welcome back to the TheMKLabs. Good to see you here. A quick thank you before we start. The response to the video 1 on how testers are unusually well positioned for AI has been generous. The comments, the shares, people who searched on LinkedIn and reported back means a lot. Today is the next one. This is module 1, Eval-Driven Development for AI. Most AI courses start with prompts. We are going to start somewhere else entirely. If you watch the founding trilogy, this is the practical build for video 3, the cascade made real. If you didn't go check it out, it'll make a lot of sense. 20 minutes, one idea. By the end, you will have a runnable evaluation pipeline. Actually, runnable, not theoretical. And a workflow that makes prompts the easy part, not the hard part. Stick with me. Let's go. Alright then, this is the module 1 of Get Started with AI for QE in 2026. I am Manoj Kumar. This whole module is one idea, and we're going to spend the next 20 minutes earning the right to it. Stick with me. By the end, you will have a runnable evaluation pipeline, as promised. Let's go. Look at this. 2 engineers, same prompt. They both want to improve it. Engineer A says this feels better and ship it. Engineer B says the pass rate went from 62% to 84% and ships it. Only one of them is doing engineering, the other one is doing vibes. That's the entire premise of this module. If you already know which one is the engineer, you're 80% of the way there. The rest is mechanics. And one note, if you watch video 3, the trilogy closer, this is the build for what you saw. The cascade made real. If you haven't watched video 3, go check it out. We'll teach you what matters as we go. That's Eval-Driven Development and the mantra for the entire module. Write this one down, screenshot it, put it in your monitor. Forget prompts, start with the test. If you remember nothing else from video, remember this line. This is the inversion. Most courses teach you to write a prompt, look at the output, tweak the prompt until it feels good. We are going to flip that up. Right? Let me give you an analogy. Think about building a house. You don't pour the foundation, step back and say, looks about level to me. You set the standard first, the blueprint, the building code, the inspector checklist, and you build to pass it. The eval is your building code. The prompt is just how you pour the concrete. Nobody signs off on the house because it feels sturdy. Or think about a GPS. You don't start driving and hope each turn feels closer to where you're going. You enter the destination first, then the route follows. The test is your destination. The prompt is just the route, and once you know where you're headed, you can swap routes freely, whether it's a freeway, motorway. Always tell which one actually got you there faster. One more for the cooks. A serious kitchen writes the pass condition before service. The dish is done when the sauce goes back to the spoon. When the internal temperature hits 75 degrees. Serious kitchen writes the pass condition before service. The dish is called done when the sauce coats the back of the spoon when the internal temperature hits 75 degrees. They don't plate it when they feel it's ready. Define done first, then cook towards it. Same move we are making with prompts. Write the test first, then tune the prompt to score it. That's the whole module in one line, to be very honest. Why does it matter? Let me show you in numbers, right? So without evals, prompt A looks good. Prompt B looks better, prompt C may be best. Nobody knows, you're guessing. You're picking the vibes. With evals, prompt A is 62%, prompt B is 71%, and prompt C, 84%. Now you know. Same engineers, same prompts, but different decision rule. Here's an analogy, right? Looks good is saying the soup tastes about right without ever picking up a thermometer. Scores 84% is reading the thermometer. One is the hunch, the other is a measurement. And only one of them survives an argument. When 2 people disagree about the soup, the thermometer wins, right? You have a validation. When 2 engineers disagree about a prompt, the eval score wins. Or think about the gym. I feel stronger this week versus my bench went from 60 kilos to 75. Same body, same training, but only the number tells you whether you actually progressed or just had a good day and a flattering mirror. The eval is the barbell. It doesn't care how you feel, it just tells you what you lifted. And one for navigators. Before instruments, pilots flew by feel. And in cloud, fail is a liar. It will tell you you're a lever while you're in a slow spiral. The instrument panel is what made flying defensible and more safer. Evals are your instrument panel for AI. Without them, you're flying behind a very confident team, which is a dangerous combi. This is the difference between AI work that's defensible and AI work that isn't. Imagine reviewing a pull request where someone changed the prompt and you cannot tell if it made things better or worse. That's the world without evals. And that's the world most AI shops are living in right now. And that's not the way forward. And you have done this before. Here is a bridge for QE folks watching, and that's most of you, right? Eval-Driven Development is just TDD for LLMs. Yeah, that's my opinionated view. Look at the rest, the traditional development. Write the code, test it later, find bugs and prod. TDD, which you have been doing for 20 years, right? So you write a failing test, write a code, and then say it green. Well, in the eval-driven AI world, write the eval, tune the prompt, score it. Same shape, different content, different vocabulary. You've done this before. You just don't know it yet. The instinct is old. The vocabulary is new. That's the only thing we are closing in today. Okay, so let's actually define what an eval is in plain language, right? An eval is a function, takes an AI output, returns a verdict. That's it. That's the definition. It's a checkout. Output goes in, pass fail, with scores come out. The verdict can be deterministic, required fields present, it checks for chase and parses, the number is in the range, or probabilistic. Another LLM scores it against a rubric, or humans, somebody on the team reviews a sample. Same shape regardless. Cascade, which we will see next, is just stacking this checkers in cost order. Here's architecture, the 4-layer cascade. You've seen this before. In video 3, you're seeing it again. Today we build it for real in code, right? Layer 1, schema. Required fields present. Today we build it schema. Required fields present, types correct, sends per artifact. Cheapest check you can write. Layer 2, properties. Invariance hold, boundary cases pass, still sends. Layer 3, model graded, a judge LLM scores against a rubric, dollars per artifact, much more expensive. Layer 4, human samples, a rotated reviewers, the last line of defense. Each layer catches what the previous couldn't. Each layer saves the next from running on garbage. And this is why the layering works. Fail fast, spend low. Look at the funnel. Layer 1, schema runs on 100 artifacts, 80 survives. Layer 2, properties runs on 80 and 30 survive. Layer 3, the model graded runs on those 30, 5 survive into layer 4 where human sample. Layer 3 sees 30 artifacts, not 100, and that's the huge difference. And layer 4 sees 5, not 100. I hope you can do the math for your chat. That's how you afford evals at scale. This is exactly the same logic as your CI pipeline. Linter, unit, integration, smoke. You don't run 10-minute smoke test on every commit. You filter. Cheap checks first, expensive checks last. Same shape, different context. Let's get more concrete. Here's a running example for the rest of the module. Keep this in mind, right? So the bug report summarizer. Take a raw bug report, the kind you have read this 1,000 times. Output 3 structured fields, severity, component, reproducibility. That's it. That's the task. We are going to wrap an eval pipeline around this. 5 steps. And the example is intentionally boring. The point isn't the AI, it's the eval scaffolding around it. By the end, you will see this is the same scaffolding regardless of what AI systems you're building. Bug summarizer today, customer support agent next week, anything else after that, you could put that for yourself. Comment below, putting these different cases on the same framework that we're going to see in the next few slides. I'll be more happy to see how you build it. Step 1, layer 1. The schema check. This is your linter. Does the output have all the required fields or the types correct? Look at the code. 5 lines of pedantic. Severity must be one of P0 to P3, a literal type. Component must be string. Reproducible must be at least 10 characters. That's it, 5 lines. And this catches half the failures before any LLM scoring runs. Half. And pedantic's free. The judge LLM costs money. Always start here. Step 2, layer 2 properties. Now we get specifics, not just shape, invariance. Look at the code, the known components. The iOS, Android web backend from a canonical list. Reject anything else. Reproducible must not contain the PII data. We scan for emails, phone numbers, SSNs. Reproducible must be at least 5 words, and a P0 or P1 severity has to mention a failure mode. Words like crashed, down, broken. Look at the code. Known components, iOS, Android, web, backend from a canonical list. Reject anything else. The reproducible must not contain PII. We scan for emails, phone numbers, SSNs. Repro must be at least 5 words. And a P0 or P1 severity has to mention a failure mode. Words like crash, down, broken. Property checks. Or your boundary value analysis instinct in code form. Every QA practitioner watching has been doing this for more than 2 decades. Different vocabulary, same muscle. Step 3, layer 3, model grade. Now we go where deterministic code cannot reach. Things like a repro is clear. Is the summary actionable? Could a new engineer triage from this? We have a judge LLM score the output against 3 criteria: clarity, completeness, actionability. And we can go and add more like answer relevancy, hallucinations, different metrics. This is where the frameworks like Eval gives you all of those different metrics baked in. Each is scored 1 to 5 with a threshold to pass. Look at the rubrics. It's YAML. Non-engineers can tune it without touching Python. The judge rereads it on every time. And one critical detail, the judge has to pass its own test. 2 runs of the judge on the same artifact must agree. If they don't, the rubric is broken, not the model, and that's the calibration we're talking about. So that calibration is very, very important. If you're using DeepEval, PromptFu, there are different frameworks in the AI ecosystem, right? So these are evaluation frameworks with metrics, and it's a metric engine. So what do you do with a metric engine? The calibration, and that's where most of your eval strategy looks into it. Step 4. The golden set. This is your test data, curated, handpicked. Roughly 30 to 100 items to start, growing to 500 as system evolves and matures. Each item is a real input plus the expected behavior. Some are clean, should pass. Some have PII, should fail. And layer 2, some are too short, should fail, layer 1. Some look confidently wrong on purpose, should fail on layer 3. The golden set is the most underrated artifact in this whole module. Spend time on it, take your time. Quality of your eval is bounded by the quality of your golden set. If your golden set is sloppy, your pass rate means nothing. Step 5, run it, and that's very, very important. This is the runner. Load the golden set. Calls the summarizer on each input. Cascades each output through the 4 layer. Reports pass rate per layer. That's the loop. That's what you ship. And the output looks like layer 1 is 86%, layer 2, 71% of survivors, 3, and the overall pass rate to 40%. That's the number you tune against. Change your prompt, rerun, watch the number move. Now you're doing the engineering work, not the eval vibes-based testing. Now you know what these are called. Golden set is just test data. Rubric is acceptance criteria. Judge model is peer review. Pass rate is regression coverage. And drift is regression. This is the table I wish I had when I started. The right column is your QE muscle, more than 3 decades of it. The left column is what the AI engineering world called, but in a different terminology. You just build every one of these in the last 5 steps. The vocabulary follows the doing, not the other way around. And that's why we moved it here, not earlier. So you have anchors now. And here's where prompts re-enter the conversation, not as the foundation, as levers. Prompts are levers. You turn them into improving eval scores. The prompt is not what you're testing. The prompt is what you're tuning. This is the inversion. Most courses spend their entire runtime on prompt techniques. Chain of thought, few short system messages, all of that. None of that matters until you have an eval to tell you which prompt is actually better. Prompts aren't the foundation, the eval is. And this is what real AI engineering looks like day to day. A tight loop, 5 steps. Run evals, read failure modes, tune one knob, rerun evals, and score. Did the score move? Ask yourself. Repeat until the pass rate is above your threshold. And the knobs, which is the prompt, retrieval, temperature, modal, judge model, threshold. Tune 1, watch the score. Don't change 3 things at once. You will never know which one mattered the most. Same discipline you use when triaging a flaky test. Isolate one variable, measure, and then move. And here's what the loop gives you. Defensible. Every change is justified by a score. You walk into a code review and say, this prompt change moved pass rate from 62 to 84. That's defensible. Reproducible. The same eval runs anywhere. On your CI, your laptop, a colleague's machine. Measurable, pass rate, drift, cost. One dashboard. All on one dashboard. Makes it easy to look at it. Production grade. This is the only kind of AI that survives production. Everything else is a demo, and the demos are how you ship hallucinations to customers. Know the real difference. And that's module 1. Now that you have an eval, let's open the box. It's testing. Module 2, we will look at more on what's the anatomy of every LLM call. The engineering behind the tokens, the context window, temperature, system versus user messages. In the previous slide, we spoke about working on the knob. And in the next video, we will see in detail about these, and which will help you eventually to turn that and tweak and tween and tune the knob. And again, as I mentioned, you will see on tokens, context windows, temperature, system versus user messages, cost on the screen, what actually happens between hi and the model response back. You will need the mental model before we get into RAG and agents in later modules of this playlist. So next week, let's look at module 2, the anatomy of an LLM call. That's a wrap. Eval first, or you're guessing. That's the line. You see a GitHub link there. I have not posted anything, so don't get disappointed. This is for a future reference, as I will start to open up an exclusive GitHub repository for super fans of this YouTube channel. But if you can't wait until then, post it on LinkedIn, tag me, DM on LinkedIn, or Instagram, email TheMKLabs@gmail.com, and you'll get. Subscribe to the channel, share with your network. See you in a week. Until then, take good care of yourself. Thank you.